Welcome everyone to the Agri-food and Health track of the HFSCon 2021. I won't steal much time in presentation. I will pass the microphone to Gabriele Scarton, software developer at Group of Us, who will present us a trap monitoring system for remote monitoring of fields. So Gabriele Scarton, thank you for being here, and the stage is yours.
I'm a software developer for Group of Us. Group of Us is a medium company, is a group of other company. We have a TNG for repairing service, Foss Green Tech for technology transfer, and also for Foss Green Tech we have an innovative startup incubated here in Oitech Park called Piano Green. Then we have Foss, the operative holding in Genova. Web Group of Us for international project that will present multimodal system for personalizing post-stroke rehabilitation in this track today. And in Rebus, specialized in digital learning, which will present its approach to gamification tomorrow here at SFSCon. So, the project. The project Drone on Traps aims to providing a demonstrative system for real-time and crop disease monitoring. The partners are Maptech as a project leader and FOSS as a project partner. The project lasted 8 months and it was funded by the DIVA project, which was funded by Horizon 2020 program. So, the project is composed by two subsystems. The smart traps installed on fields, which provide a photo every day in a dashboard, and drone scans make sporadic for a complete scan of the crop. For the UAV system, I don't speak because there is the topic of the next presentation here, same track. So for the trap, our goal was to make a smart trap easy to install, so no cable, wireless communication, low maintenance, in order to install it at the beginning of the cultivation, and then remain the trap here for months. So we need also to communicate with the trap remotely. We designed the trap with a unique form factor with a CAD software. And for the electric part, we have a lithium battery and solar panel for recharge them, a computational unit to control the system, a wireless communication module to send data, and camera and sensor to get the data. The structure was printed with a 3D printer here at NOI Makerspace. It's divided in 3 parts. The top, which is the container for the hardware. The middle, which is empty and it's used for weather protection and for installing the solar panel. And the bottom part, which is a case where the glued trap sheet for detecting the pest are placed. For the hardware, we use off-the-shelf components, and we found 2 working configurations, one with single-board computer and one with system-on-a-chip microcontroller. The first one is more powerful, it's easy to use, and usually use verified hardware, so we have a single reliable source which provides always the same hardware, and there is a lot of documentation online and a lot of sensors are easily compatible. On the contrary, on the system-on-a-chip microcontroller configuration, we have a very low energy consumption in order to make the trap last 4 months. We need specific firmware for the hardware, but also we can model the firmware for our needs. Usually it's an open hardware, so it's cheap, but the hardware comes from multiple manufacturers, and everyone makes some little changes that we have to handle. And also it has a small size compared to the single board computer. So which is the best configuration? It's difficult to say, because single board computers are simple and provide better results in less time, but cost and energy consumption are really, really high. On the contrary, on the system-on-a-chip microcontroller, we have the perfect solution for the task in theory. In reality, it requires a lot of time to build the perfect firmware and also to check every hardware, because it comes from different manufacturers with little small detail that complicated a lot the assembly of the trap. Now that we have the trap, we need to have the data available for the customer. So we also set up a server which receives the data, process the data, and make them available as fast as possible. Also, we need to manage different sources and users from fields. So for communication, we use GSM, which is not very fast, but provides great coverage and is not expensive. The communication was VPN protected, and we use SSH and FTP to communicate with the trap and sending the data. For processing the data in the server, we divided in two phases. The initial one, where we use ImageA, a software image processor tool in Java, which processes the image based on color and morphological operation to reduce the noise. And then the result is validated directly by customer or researcher directly in dashboard. After we collect some data, we switch to the stable phase where we implement computer vision algorithm to make the same the same process and the same human validation on dashboard. To make the data available as fast as possible, we set up a Linux server with iNotify tool library, which execute a script every time a photo is arrived in the file system. And the script process the image and save the data in a MongoDB database. We choose MongoDB because it's a non-relational model and give us the maximum flexibility in order to use any type of sensor or data maybe in the future, and to alert the customer as fast as possible. We also implement a Telegram bot for real-time messaging. In order to manage different users, different fields, and different traps, we implement the dashboard in order to manage them directly on the web, and also we make the user interface mobile friendly to use them everywhere. So, for concluding, Drone on Trap project is a large-scale demonstration success because we get working trap configuration, we have a successful pest detection, and we were able to handle multiple client, customer, field, and traps simultaneously. But also, the project needs more work. We need to improve hardware configuration to improve the trade-off between times and cost. And we need more data for AI model in order to classify also the pest and not only detect them. So this is the end. Thank you for attention. I'm here for questions.
Thank you for the nice presentation. Anyone has questions or a question to pose to Gabriele? Please, can you do it at the microphone?
Sorry, just a very basic question. Can you make an example of pest? I really don't understand which is the information that you detect.
Pests are, for example, Pomonella for apples, moth. The idea is that there are on the market some traps which are the case in plastic where you put the glued sheet, you put pheromones on it, and then the moths are attracted to the glued sheet and they remain here. At the moment, the farmers need to go to the field to check with eyes the sheet and so if the pest arrived or not. With this smart trap, we make a photo of the sheet and we send it in almost real time. Okay. In the same day, the customer have the photo.
You can make a remote detection of these diseases of the plants.
Yes.
Okay. Thank you.
Thank you.
Anyone else has questions? So I do have one.
Okay.
Do you plan to make and help the people to understand when they have to do some treatments in the fields, or use this information combined with AI to to provide a support system, a decision support system.
Yes, we provide a decision support system, but the final decision we let the decision to the farmer. We provide the data. If needed, we can add information, for example, to the Telegram bot. For example, we found 10, 20 or something pest in the sheet. It could be a problem, so we can send a specific message, but then the decision is on the farmer.
Okay, and which was the most difficult pest to recognize?
There are some moths that are very difficult to recognize because they are similar to other, and there is only a little point in the back of the moths to identify them from normal moths, and this is very difficult to find it because every moth is attached to the sheet in different positions, so maybe this point is also covered, and also quality of the photo is good, but we cannot zoom so strong for detecting a few pixels of this point. So this moth, if I remember correctly, for apple is very difficult to identify.
We have another question.
So do you recognize the different type of pest and send like it gives also statistics, so you can see in my field there was found 100 of this type, 50 of this, so you have also statistic on the different kind?
Yes, this is the final goal. We are working on it. We got some result, but as I said before, we need more work to make a reliable system for identify every moth in the sheet.
And the second question, do you have also already some field studies here in South Tyrol where you do test your system?
Not in South Tyrol, but we continued the project, not the drone on trap project because this is ended, but the idea of smart trap, we are continuing to developing it. Yes, we have some trap installed in Italy, not in South Tyrol.
Thank you.
You're welcome. We have an online question. Denveg ask us, where did you fix the traps? Only on trees?
It depends. We work mostly on apple and olive, so it was easy for us to install them on trees, but it depends on the task. That's why we choose to make a 3D printed model. So if there are special needings, we can think of change the configuration of the trap to make them suitable for other tasks. But usually we speak with farmer or researcher to make the form of the trap if there are special needings.
Okay, we have 15 seconds left, so thank you really for your presentation, Gabriele. It was nice to hear you, and thank you again for being a speaker.
Thank you.
Agri-food and health track. The next speaker is Gianluca Ristorto, R&D engineer at Naftec. It's an online speaker. He will present the part 2 of the project presented before by Gabriele Scarton. Okay, now we are ready, and I pass the virtual stage to Gianluca.
Russian, can you hear me well?
Yes, we hear you well. A little bit
Okay,
loud,
I
but
start.
well.
I start. Okay. Yes, this is the quick summary of my presentation. In the first slides, I will show you their scenario where we have developed our project, Drone Trap. Then I will present you the main objective of this project that some words already said Gabriele in the last presentation. Within this project, we have developed and tested three technology, a ground technology, a flight technology, and a web architecture. Then I move to some example of monitoring campaigns, and finally some conclusions and future works to further improve our technology developed here. Of course, related to the scenario that we have employed these systems, we have focused on the health status and pest management programs to support agronomists and farmers to reach effectiveness in the application of the right substances for what concerns optimize the timing in the applying, for example, fertilizer or pesticides, as well as to reduce them in terms to reduce the quantity and use them only when they are needed. The project is focused on the Cydia pocomonella insect that is an insect that strongly affects orchards, for example, apple orchards and pear orchards. As Gabriele said before, the main goal of Drone Trap project is to provide a large-scale demonstrative system for real-time and remote crop disease monitoring to facilitate the workers in agriculture in the organic actual production to drastically reduce the cost of crops inspection, thanks to the technologies that we have developed in this project, and to give information them to reduce also the use of pesticides and fertilizer using precision farming techniques. The system that we have developed in a Drone Trap project is composed by intelligent traps installed on field that monitors in real time the status of dangerous insect attacks, as well as we use drones, UAVs, for a complete analysis of the status of the crops. This project has been conducted in collaboration with FOSS, the company represented by Gabriele, and also by the external consultant Astra Innovation, that is a company that works in the field of agronomic services that help us in the validation of the technologies and the methodology to make these monitoring activities. The project has been conducted last year in 2020 and has been funded within the DIVA European project. So the system that the technologies that compose the overall system are the intelligent apps developed by Group of FOSS and now commercialized by Piano Green. That I go very quickly. They are very easy to install, like plug-and-play systems, and then they can be integrated with the already existing monitoring activities. Thanks to the use of photovoltaic power and the rechargeable battery, they have low maintenance, and through the 4G wireless data communication, they sense at a programmable interval the photos of the traps of the glued sheet that is installed inside the traps that contain special glues that is capable to attract the dangerous insect like Cydia pocomonella, that is the insect that we want to investigate if is attacking our field or not. The drones that we have developed for this project is the Mavtec Q4E, that is a multicopter that has 4 rotors, is very narrow in size. The dimension from the tip of the blade to the other tip of the blade is about 1 meter. Its maximum takeoff mass is of about 4 kilograms, and it is capable to transport sensors of about up to 600 grams. Typically, the survey speed is of about 4 to 6 meters per second, and depending on the resolution that we want to obtain from the images taken from the sensor, the drones is capable to make flights from 30 to 70 meters above the ground. The endurance is of about from 15 to 20 meters, and with one mission we are able to monitor from 4 to 5 hectares per missions. The drones is also equipped with an RTK GNSS system that is capable to travel precise navigations, and also this GPS, the information coming from this system are also used to precise georeferencing the images coming from the payload installed on board. The sensors that we use to estimate the actual status, health status of the vegetations is the MicaSense Red-Edge M multispectral sensors. That is a camera that has 5 acquisition bands from blue to near infrared that allow us to obtain information about the health status of the crops. Thanks to the use of a downwelling light sensor as well as a calibrated reference panels, the images that we obtain from this sensor are radiometrically calibrated, which means that we are able to compare surveys carried out in different periods of the season without the problem to have different light conditions. So the images that we obtain from this sensor can be compared also in different periods of the season and also in different light conditions. Depending on the flight depth of the drone, so we can obtain photos at different resolution that ranged from 10 centimeters per pixel if we fly at 120 meters above ground level. For example, if we carry this sensor on a fixed wing UAV, while if we would like to obtain very high resolution images, we can fly it also at 30 meters above the ground. We will obtain images at a resolution of 2 centimeters per pixel. The images coming from the automatic trap as well as the images coming from the drones are sent to our web server platforms, where there is a dedicated panel to manual count the targeted insect that the camera of the intelligent trap have recorded, as well as there is also a machine learning algorithm that automatically detects the pests and count them. Furthermore, we can also integrate in this web platform information, for example, relative to the micro and soil climate parameters, such as temperature, humidity, and so on, that could help also the agronomists in the decide if some action are needed on the orchards. During the 2020, we have conducted a series of monitoring campaigns in 3 different fields in Emilia-Romagna regions. In the fields of Dosso and Renazzo in the province of Ferrara, we have monitored for both fields 1 hectare of organic production of pear orchards, while in Villa Prati, in province of Ravenna, we have monitored about 3 hectares of, also in the case, organic apple orchards. This is an example of the monitoring activities. So we have placed our intelligent traps in the fields, as well as the consultant from Astra has placed standard traps, not remotely operated, to conduct the validation of the system. In parallel, we have carried out different surveys during the growth season with our drones, and we are able to produce maps by using the information coming from the multispectral sensor. The most popular thematic maps is correlated to the NDVI index, that is a vegetation indices that use red information and near infrared information from the multispectral sensor to have a correlation with the health status of the crop. So in the images in the bindle below, you can see that the health status of the crops has a green color, while the portion of the orchard who is in stress is colored in yellow or red. In the top, in the right down of the images, you can see also the thematic maps that we produce by subdividing the row of the orchard in parcel, and inside these parcels we evaluate, for example, also in this case, the value of the NDVI index, and thanks to some calculation, we are able to detect inside these fields if a parcel is subjected to stress or not. Then the agronomist went to the field and evaluated the cause of this issue. So, in conclusions, thanks to the involvement of Astra Innovation, we was able to say that the smart traps from FOSS are as efficient as standard traps in Moth-Cactus, but also, as illustrated by Gabriele, we need some further tuning to detect the targeted species with sufficient reliability. And we have to introduce some additional development on machine learning algorithms to obtain these reliable results. One of the outputs of the monitoring campaign with the UAVs is that because insects affect only the fruits, the images coming from the drones, the multispectral images, are not strictly correlated with the health status of the plant, of the orchard. So we need further analysis, further investigation to obtain, to detect, to obtain new methodologies for a better estimation on the correlation between the pest attacks and the aerial surveys. And finally, because some orchards in Italy are covered also by anti-hail nets, we would like to investigate the spectral response of these kind of crops, in particular to use this same approach that we used in the drone trap project, also in any application scenario.
Thank you, Gianluca, for your interesting presentation. Unfortunately, we do not have time for questions since you were just in time with your presentation, but anyone who wants to continue discuss the topic can use the Element channel online and chat about the topic. We see us in around 4 minutes for the next speaker. So welcome back to the Agri-Food and Health track of the SFSCon. The next speaker is a speaker of URAC Research, Ekaterina Chepikova, and she will present an analysis about the apple data to identify the perfect South Tyrolean apple in South Tyrol. So welcome on stage. Thank you for the presentation, and the floor is yours.
Become an essential part of analysis any data sources and especially heterogeneous data sources. In this talk, I would like to present you a data-driven solution for apple variety testing program conducted here in South Tyrol. Being an interdisciplinary topic, it requires contribution of scientists from different fields, from agriculture, our colleagues from Limburg Research, so they are working on a breeding program, colleagues from University of Bolzano, and also my direct colleagues from URAC Research. The objectives of this ongoing research project is to establish a common data space enable to synthesize knowledge about apple variety program in South Tyrol and derive insights from heterogeneous environmental data. And second is to create a single visual analytic user interface able to retrieve knowledge from data. This project unites four recent significant inquiries such as data visualization, data analytics, agriculture, and ontology. So obviously is the abbreviation of this research project. Here we deal with apple variety testing. So variety trials are essential part of breeding programs and production. It requires a high investment of time and resources, and it results in collection of large amount of data about variety performance in different environmental conditions. Variety testing program conducted by Limburg Research is done on the 3 phases. So the first phase this project deals with the first data from the first phase. Is data collected about collected over more than 30 years about plantings of different apple varieties in 2 microclimatic zones. So each variety is planted for 4 or 5 years, and then the data is collected about the performance of this variety in this environmental, so in this microclimatic zone. There are 2 main test sites. So first test site is in Limburg on the elevation of 220 meters, and another main test site is at Lach, 700 meters. These 2 sites, they have different climatic conditions and also different pedoclimatic conditions, of course. The data consist of large varieties, so information about different mutant groups and also genotypes that belong to these different mutant groups. For instance, each mutant group, as Golden Delicious or Fuji, includes different clones and crossings. And each of these crossing or clone also includes information on general characteristics that belong to this genotype, and also information about annual performance of this mutant group. Database includes information on, for instance, time during the time when the flowering started, when it's finished, some field measurements, and also information collected at harvest, such as weight, for instance, color sorting, fruit size, and so on. Each variety is stored according to its individual characteristics, stored for certain time. It can be up to 3 months, and then data is also collected at the post-harvest phase. In the same time, we also have information, long-term information on climate, on temperature, which is collected sometimes at the site of the orchard, and some stations that are outside of the orchard, but this information can be merged with information about apple variety performance. So by merging these 2 data sources, we can retrieve more knowledge on how varieties perform during time. And also we see in retrospective, but then the interest also to see how it might develop as the climate change takes place and the temperature is changing at the higher rate than especially in pessimistic scenario, temperature is changing at a higher rate, then a new variety can be investigated. So the mean temperature is also varies during the growing season, and also it varies during within the different years. So and all this information is interesting and is necessary to integrate together. So apple variety testing and information, and also climate information. What can we know about? What can we know by combining such data sources? For instance, how elevated temperature, maximum temperature higher than 35 degrees, may affect the apple variety performance. For instance, how the color and size is changing, if a variety experienced certain elevated, days with elevated temperature. Or we can also investigate how growing degree days index vary between different years, and how this extended period of growing degree days might affect the yield of each individual variety. Besides, we can also analyze how sugar content varies between different years, as we know that some years have a higher temperature than the others, and sugar content directly dependent on the temperature during the growing season of apples. So this data, the temperature, let's say climate data and variety testing data, there are two data sources. They are heterogeneous, and they are heterogeneous because they have different granularity, they have different spatial temporal extent, and also they are stored in a different databases, so they stored in different locations. They organize in different ways. So what can help us to integrate this two heterogeneous data together is an explicit specification of concepts and relationship between these concepts provided by ontology-driven approach. So we need ontology to analyze the domain knowledge and keep it separate from operational knowledge, then to share a common understanding about the domain, about the concepts, about the structure of the data and data types, and to define assumptions explicitly. And besides, we can make domain knowledge interoperable and reusable as we create this upper level of knowledge over the data sources that we have. To integrate data, in this project we adapt a knowledge graph approach. So this approach helps, or this approach boosts the knowledge discovery from data coming from structured data sources, from semi-structured and unstructured, and knowledge graph allows to find the connections between various data sources. To do so, the first step was to create an ontology based on the data that we already have. So the data of variety testing is organized in a structured database, as well as the climate data. And the first step was to bootstrap the information from the databases and use this semi-automatic approach provided by OnTop. So it's MP-boot is one of say functionality of OnTop that allowing to directly map the concepts from the database where data properties are data fields. So in the database, then data objects are relationship based on primary and foreign keys, and data classes are the basically tables in the database. This approach allows to bootstrap their ontology based on the database, and also to semi-automatically define the mappings between ontology and the database. With this ongoing research, so we will implement a three-tier architecture, which include on the first level is a presentation layer. The presentation layer allows to form queries and visualize the answers to these queries. Application layer includes ontology and mapping management, so query answering component, and the data layer includes different data sources involved directly into the analysis, such as variety program, so variety testing program, as well as climate data. And as a next steps will be also to involve other data sources, for instance, NDVI, so information about humidity, solar radiation, that also might give us a better understanding about the processes behind the performance of different apple varieties. Yeah. Thank you so much for your attention, and I'm looking forward for your questions if there are any.
Thank you, Katerina, for your nice presentation and interesting presentation. So now it's your turn. You have the opportunity to use 1.5 minutes to pose some questions. Is there anyone who wants to ask something? Otherwise, I break the ice. So I'm curious to know how much it is important to have a domain expert in building an ontology. So it's an important role, I think, and I'm curious to hear your opinion about that.
Yeah, domain knowledge in this project is essential. So there is so many different specific aspects of the database that it should be explained to a non-expert. So even the terms that we use within the ontology, they have to be agreed within the community. So it's not a simple translation because, for instance, database is in German, so it's not direct translation to English. So we need to consult with the domain experts to find a common terms that used in the domain, for instance. Yeah.
Thank you. We have 15 seconds, so I have only the time to say thank you again for being a speaker of the SFSCon, and hope to see you again next year.
Thank you so much. Thank you.
Bye. And see you here in 5 minutes. Okay, welcome back to the Agri-Food and Health track of the HFSCon 2021. The next speaker is a researcher of URAC Research, Abraham Mejia Aguilar, and he will present us an innovative sensor for the agriculture. So, Abraham, the virtual floor is yours.
Yeah, thank you very much. Good morning, everyone. I'm Abraham. I'm in behalf of Zain, our former colleague from URAC, that basically developed this autonomous hyperspectral sensor node for precision agriculture. And we are developing this project in collaboration with Group of Us and also some partners in Limburg Research. Yeah, so basically some basic information about this spectroscopy method is the interaction between the matter and the radiation. So this is a widespread, let's say, like a method that is it's aiming at as a non-destructive and a really precise and qualitative method for different applications. Basically, is the interaction between the energy and the element, and then we have some specific response over the electromagnetic range. Basically, our aim is studying in this range, in the visual and the near infrared range, to detect some specific characteristics in vegetation. Our main intention in this regards goes in the direction to analyze and to identify diseases by the comparison of spectral signatures. It means the spectral signature is basically the response of the energy through the element. And it basically creates a type of fingertip, let's say, that is unique to the characteristics of the elements that we are observing. And basically, it allows this method or this technique, so either to identify the species or inside of the species to determine if the quality is, the quality is good or not, and also to, in consequence, also identify some diseases. So basically, by just comparing the signatures. Yeah, in general, this method consists in the use of portable spectroradiometers that are a really high-cost instrumentation. these instruments basically are like to medium to high power consumption. It means around 70, 80 watts per hour. That if you consider to develop or to execute these methods on the field has like important limitations, because you continuously need to change batteries. You need to continuously be aware about this power. And in general, the approach of using these spectroradiometers is like is really highly time consuming. It means like if we are particularly interested to observe the dynamics of the vegetation through the year, it's basically impossible to the farmers or to the researchers to go every day or every 3 days to take these sample collections. And one of the most, let's say, like a limitation in these methods are like the weather conditions really affect the experiments. And apart from that, let's say like the limitations of the technology itself is like these instruments store the data locally in some memory inside of the instrument, and then afterwards the researcher or the user needs to download and do the proper analysis. So in this sense, we are proposing like a modular system. It means like we are using several or little independent things or modules to build this node or this hyperspectral sensor node. It basically consists of one low-cost spectroradiometer, some data loggers that are collecting either the information from the spectroradiometer or from some other parameters. It's the possibility to transmit to remote using wireless communication, and of course we are using some strategy to use it as a long-term observation based on the energy efficiency. One of the main advantages of using this modular system is that we can distribute these nodes in, let's say, in an orchard. And also the one of the big advantages is like we can position this node according to the necessities of the farmer or the necessities of the researchers. For example, we are conducting experiments like our colleague Katerina mentioned before in apples, that you can observe the canopy above the canopy, the orchard or the fruits. But the situation is totally different if we want to observe vineyards, that the grapes are basically below the canopy. So this is one of the limitations. Also, one of the advantages of putting this distributed network, let's say, is like we can generate multi-point observations. And then these observations can run during the entire season. And then we can observe the dynamics in the vegetation, how the plants are stressed because of elements, no? Either temperature or some climate effects, or even the presence of humans, no? The management itself of the orchard. And one of the other advantages of using this modular system is like we can apply immediately either in indoor or outdoor applications. So the strategy that our colleagues used was basically to put these modular parts using one of ocean optic spectroradiometer. It's a low cost if we compare with the standard instrumentation that is in the market, and using open hardware solutions, so either Arduino or Raspberry Pi. So Zain managed to program this sensor in an autonomous way to collect the signature, the spectral signature, every 15 minutes, and transmitting this information via 3G, if it was like the case in a non-remote area, but well communicated with the infrastructure. And also if the farmer has some like a Wi-Fi spot to collect this information. As a redundant system, we just implement the information in a local SD card, and all this information were transmitted, or are transmitted, in fact, to a FTP server locally in our facilities at URAC. So we are currently working in the integration of different sensing blocks. So this is the irradiance part. And also we are interested in some like a weather or meteo information, so either temperature, soil characteristics, soil moisture, etc. And also in parallel, we are creating the organization of this information in a dedicated database that further it's possible for the people or the interested people to access in Grafana visual interface. So basically, this is the two blocks or the two modular blocks that our colleague Saina was developing. So it consists in Arduino and Raspberry. Basically, as you may know, Arduino is more oriented to microcontroller strategy. It means like for the data acquisition is really robust, while the Raspberry is more like a microprocessor that you can perform some processing or calculations inside. That basically reduces all the power of computation in the servers. That it's really useful once the farmer is interested to really observe the proper time what is occurring in the field. So our group, we are like aiming at the open hardware and open access solutions. Inside of this project, DPS Forest Lab, that basically was putting all these ideas on action, let's say. The codes that we have developed until now, you can access in this GitLab repository if you are interested in. So the preliminary, let's say like experiments that we conducted were in the field also, but also in the lab. So basically the spectroscopy consists in having one reference information that is basically the response from one white panel according to the luminosity conditions in the field or in the lab. So then once you have this calibration curve, you basically point or collect some material. In this case, we were just pointing at some green object, and then we confirmed that this band was capturing specifically the band for the green spectrum in the electromagnetic range. So then we conducted also like some experiments in the field. So we are aiming, as I said at the beginning, to identify diseases in apple orchards. Then we collected this information with the two instruments, so the high accuracy instrument versus the portable one. And the main, let's say, like the good result that we collected is like they have the similar response. Of course, you can observe here like the curves doesn't match exactly. So this is due to the fact that either the resolution or the accuracy of the low-cost sensor is really low or is not comparable enough to the high-quality one. But at least we have the tendency that it means like for long period of observation, we can estimate the behavior of the plants or the object itself on the investigation. Okay, so then basically from this experiment that we are conducting and we are in fact like pushing right now, is like we demonstrate the use of low-cost sensors approaches for long monitoring systems. Of course, these low-cost sensors will never replace a high-quality instrument. But anyhow, with these approaches, we can distribute sensors in the orchard or in the field for long observation. That basically will give out the advantage to detect the stress in the plants, basically. And with this early detection, we can provide information to the farmers to act on time. And then it will, in consequence, reduce like some loss in the production, of course. Yeah, with the modular solutions, it's attractive for everyone, like to add information on site, no? So if we are collecting the spectral signature according to some specific phenomena, we are interested which can be the relevant factors that affect this, no? So, for example, integrating temperature or the lack of water in the soil or some other factors that are in consequence correlated to this signature, no? It's possible to with these like modular systems to extend the spectral, temporal, and spatial resolution. It means like with the spectral resolution, we are not just observing some specific bands like the typical cameras that just observe the standard red, green, blue, and the infrared, so 4 channels. With these spectroradiometers, we can collect up to 1,000 bands. And then it's possible to go in detail to some specific areas to detect what is happening, for example, in the near infrared, and then just pointing at some limited spectral range, for example, to detect chlorophyll. For the temporal resolution, as I said, we can install these sensors for long observations, so we are increasing the time, and then somehow these nodes are independent of the weather conditions that are usually one of the main withdrawals in remote sensing applications. When it's cloudy, for example, you cannot detect or you cannot collect the images because of the clouds. And the spatial resolution is basically improved because we can install these sensors in different parts of the orchard and even below the canopy. So yeah, it's also attractive for the researchers, of course, like all this information is on site, basically in a near real time. And we have the possibility also to integrate some sensors. And of course, one of our aims as a group, as I said at the beginning, it's like to give the possibility to some other researchers to touch these developments that we are doing, and also the possibility to some other people to access to these data sets following these standards of FAIR principle that is findable, accessible, interoperable, and reusable. From that, I basically finished my presentation. Thanks for your attention.
Thank you, Abram, for your interesting presentation. Now I ask to the publicum if there are some questions they would like to. Please, can you come and do it at the microphone?
Hello, my question is, how many sensors do you need for, by average, to get meaningful data per hectare or per certain area?
Okay, so let's say like this is more related to the experiment that we have to run. No? So in the case of detection of the diseases, let's say like hypothetically we only need two sensors, one that is pointing towards one like a healthy tree and one that is pointing to a non-healthy tree, and then we are just comparing these two signatures on the time. However, if you want to, of course, observe the entire orchard, so either you change the strategy of using then the optical sensors, it means like the imagery, the images, and then just identifying the specific bands provided by this low-cost sensor, and then covering the entire range of the orchard. Or you can also let's say like install this type of approaches in an autonomous vehicle, either a tractor or some of the standard robots like the UAVs or the rovers on ground.
Thank you.
So thank you, Abram, for being a speaker at the FSCon 2021. I hope to see you again next year with some follow-up of this interesting project. So thank you, and see you all in 4 minutes and a half for the next speaker.
Thank you very much.
So welcome back to the Agri-food and Health track. The next speaker is Gianfranco Campos, CEO of Zingar Technologies. He should have spoken about interplanetary precision agriculture. Unfortunately, he couldn't attend today, so we had to cancel the talk. So we see us at 1 p.m. for the next speaker. So we have to wait. We cannot move to the next one since the people online. We knew it now that he couldn't attend. So welcome back to the Agri-food and health track. Now we move more on a topic health. We had more agriculture till now. The next speaker is Rosita Makauskiene. I hope pronounce well her name. It's the director of Group of FOS in Lithuania, and she will present us a multimodal system for personalized post-stroke rehabilitation. So, Rosita, the stage is yours.
Group of FOS Lithuania biomedical engineering company is situated here in Santaka Valley, which is an important part of Kaunas research, technology and business community. Working in this environment, our mission is to combine Lithuanian scientific discoveries and biomedical engineering skills in order to create new technological solutions which will help patients worldwide. Last year, our team, together with the researchers of Kaunas University of Technology and Lithuanian University of Health Sciences, have patented biomedical electronic equipment for post-stroke monitoring, and it is the first solution of this kind in the world.
Every year, 15 million people suffer stroke and 5 million are permanently disabled. Early diagnosis and actions taken in early hospitalization give a chance of complete recovery. Despite the accuracy of computed tomography and magnetic resonance imaging test results, they are very expensive, have harmful ionizing radiation and limited equipment availability. Therefore, there is a clear need for a safe and easy to use portable system that allows patients to be monitored in the post-stroke period.
The equipment created in Lithuania allows near real-time monitoring and simultaneous analysis of patients' health parameters from the affected part of the brain and the cardiovascular system. The main operation principles of a post-stroke monitoring system include a synchronic recording of two groups of variables, those reflecting changes in cerebral tissue and the indicators of cardiovascular system health, which are connected to the increased risk of stroke. This information is vital for preventing the recurrence of stroke among survivors and would provide integrated advanced analysis of the collected data.
Our equipment has no limitations related to the frequency of the measurements, so it can be used unlimited times, providing doctors visual information on brain tissue changes periodically. It is portable and allows patients to make measurements from home during rehabilitation, while doctors may access this data from a cloud, compare changes, and make timely decisions for treatment and rehabilitation. Currently, we have developed a prototype of a system and started small-scale biomedical trials, which involve 10 patients.
We operate in the brain stroke monitoring market, which was 5 billion euros last year. We plan to present our system to the market in 2023, starting from our home markets in Lithuania and Italy, and then expand to EU, USA markets reaching over 10 million euros income annually. The fruitful cooperation experience with companies, universities and health institutions will give a great impact on the successful commercialization. The road of medical technologies to the patients is very long, especially when the invention is complex and its efficiency needs to be proved by clinical research. Potential investor funds will contribute to completion of the hardware and software of the system, conducting larger-scale biomedical trials, carrying out pilot production, certification and scale-up of innovation to international markets. We already have a working prototype and started small-scale biomedical trials at Kaunas clinics. With the support of potential investor, there is a great opportunity to bring this patented equipment from Lithuanian lab to the world market for the benefit of medical personnel and patients.
Rosita, you can start your presentation.
Thank you very much. I am very glad, and it's a great honor for me to present our path from Italy to Lithuania and how we implemented the international project multimodal system for personalized post-stroke rehabilitation. In 2015, Group of us, which works in IT, telecommunications, automation, engineering area, opened the biomedical engineering lab in Lithuania. Later, we built strong consortium with Lithuanian educational institutions, Kaunas Technology University, the University of Health Sciences, attracted EU funds and created biomedical engineering equipment, which last year was patented in Lithuania. And we are glad that this year, in 2021, the patent was expanded to EU, USA, and clinical trials started. What problem we are solving? Group of us Lithuania is solving world-level problem. Each year, worldwide, 15 million people suffer stroke. 5 million of those die. 5 million are permanently disabled. And currently, when a patient shows symptoms suggesting a stroke, he is transported to the hospital for computed tomography, CT, or magnetic resonance, MRI procedure. MRI and CT are characterized by high-resolution 3D imaging, and for neurologists, it's a golden standard. However, both have its own drawbacks. MRI scanning takes long time, there are contraindications, it's quite expensive treatment and very sensitive to movements. The machinery itself is quite bulky, large. CT exposes radiation, and if it's done too early, may not see difference. It also can see lesions not always specific for stroke. The machinery is large and big and bulky as well. We are working to help those 5 million patients, creating a biomedical electronic equipment for the post-stroke monitoring, and our goal is to provide the doctor with additional data in real time. In this way, increasing patient chances to leave hospital with a minimal residual effects after stroke. Helmet is dedicated for neurophysiological measurements. Wristwatch is used for cardiovascular measurements. This new equipment is safe to use, will not use radiation or strong magnetic field. It's affordable due to low construction costs. The data is available in real or close to real time from everywhere in the world. The equipment itself is light and mobile, and it can be conveniently used by patients not only in the hospital but at home as well. Within the second project, we added multiple modalities to the system, and in order to have additional resources of information for better understanding the progress of rehabilitation, we expanded neurophysiological measurements with FNIRS and EEG subsystems, and on top of cardiovascular measurements, we added neurophysiological measurements and gamification through virtual reality. In conclusion, the new system, which is still under the development stage, will be useful equipment not only for doctors, rehabilitologists, but also for patients who could track their personal progress at home. System consists of 4 subsystems, which are responsible for, first, neurophysiological measurements, cardiovascular measurements, neuromuscular measurements, and virtual reality. Here we have all 4 subsystems presented separately, and we are glad that to announce and to have the stage to present that the equipment is the first in the world integrated health monitoring system for stroke survivors, and it was patented in Lithuania in 2020. The inventors and the group of people who are working in this project consist of 3 consortium parts. It's a group of us Lithuania, the University of Kaunas Technology, and also very important part and contribution is from neurologists who work in Lithuanian University of Health Scientists. We are glad that all this invention was already published, and the press release links I'm willing to share with you. At the moment, we are going through the CE certification stage and implementing the security tests. Also, clinical trials, which are implemented in the Kaunas clinics, and the main researchers, neurologists, Professor Rastenytė and Matjošaitis are in charge of these trials. And we received the permission of those trials this year in February. And at the moment, already 4 patients are tested, and optimistic data is received and will be presented later in the articles. As I mentioned before, and it was presented in video, we this year already expanded our patent to EU and the USA. The patent is called Method and Biomedical Electronic Equipment thereof for monitoring human condition after stroke. And the prototype is ready. LT patent is already on our side. Science acknowledgement is already aware. And at the moment, we are at the clinical validation, product validation stage. We are implementing customer evaluation, patient review, And as I mentioned before, the expansion of the patent to other markets also is on the way. And in conclusion, last year, our group of FOSS Lithuania created the most innovative products and services in 2020 and received the Lithuanian Award for this achievement. And also our company made the biggest impact for the Lithuanian startup ecosystem. So we are proud to share this achievement with you today. And we strongly believe that the system which we develop with Lithuanian and Italian partners will help those millions of stroke patients every year to get back to normal life. So Lithuania is the place where innovative Italian technological ideas which will help patients worldwide are implemented. Thank you very much for this opportunity to share these achievements with you today.
Thank you for your nice presentation. I hope that Lithuania and Italia will be pioneer in these technologies. There is someone that has question from the publicum. You can.
Thank you, Rosita, for your presentation. If I have understood correctly, you have a part of your system that does rehabilitation of patients. And through virtual reality and there are also physical rehabilitation. Can you tell us a bit more about this part of the system? Thank you.
Okay, talking about virtual reality, with specified tasks, it gives motivation for the patient to pursue the goal of recovery. It also, this additional subsystem also helps for movements recovery by internal and external feedback. It helps to implement the specified tasks and adaptation to the patient needs. Depending on patient, it can be projected in the monitor or VR glasses and controlled with a keyboard or VR controller. And that even after end of the rehabilitation in clinics, patients would be able to continue this rehabilitation at home with a provided system. So this is very important, was, to our neurophysiological and cardiovascular measurements to add this virtual reality and gamification, because it helps patients to analyze their process themselves, even without the doctor's intervention and control. And that's it's kind of a tool, a motivational tool for the patient, to get better, to get faster to the better stage of health. So we are glad that we managed to implement this and add this subsystem to the neurophysiological, to the helmet as we call it, and to the wristwatch as we had it before.
Thank you for your presentation, Rosita. Thank you again. I hope to see you next year at the SFSCon for an update of this interesting project. So we see us in 4 minutes and a half for the next speaker.
Thank you very much. It's a great pleasure.
Thank you. Bye-bye. So welcome back for the last talk of the Agri-food and Health track. The last speaker, but not less important, is Floriano Zini of the Free University of Bolzano. It's a researcher of the Smart Data Factory, and he will present a computer-based cognitive training system with reinforcement learning. So, Floriano, the floor is yours.
Thank you very much. And this is a joint work with colleagues from University of Bologna, Fabio Leppiane and Mauro Gaspari. And it's about cognitive training and rehabilitation. So it's in some way linked to the previous presentation. The computerized cognitive training is getting very popular. There are many systems that try to use computers for presenting brain games to people, to patients, but also to healthy people in order from one side to, for example, do rehabilitation for some diseases, or more in general to enhance mental performance of healthy people. There are promising results that have been achieved in research studies on this field, and we have developed a specific system for cognitive training and rehabilitation that is called MS-Rehab. It's dedicated to patients that suffers from multiple sclerosis, and has been developed in cooperation with clinicians of some hospitals in Bologna and Modena. And these systems provides services for patients that can do rehabilitation exercises that you see on the right side, but also services for the clinician that can set up a rehabilitation session, training session for patients. It's a common web application. This is a very typical architecture. All the components are free software. And these are the cognitive training exercises that are provided. There are exercises for attention, memory, and executive functions, and for a total of 52 different exercises. And the main features are that the patient can stop an exercise and restart it later. A feedback is given to each patient at the end of the exercise, and this feedback includes the performance obtained and which are the correct, wrong, and missed answer in the exercise. We have evaluated the efficacy of this system in a clinical study. It's a preliminary study with 8 patients suffering of multiple sclerosis. They have done, they have been evaluated. Their cognitive performance has been evaluated at the beginning, before the treatment. Then a treatment with our system has been executed, and these are the exercises that were executed by the patient in the rehabilitation session. And then the evaluation of the cognitive function was done after the treatment in order to see if there was an improvement. I don't go into details, but we did we measured both neuropsychological parameters, for example, verbal comprehension, working memory, and others, and also some psychometric parameters. And you can see for many of these parameters, there were an improvement between the value obtained before the treatment and the value obtained after the treatment. The rounded, the values that are in red, this means that there is a statistically significant difference. So this means that the system is really effective. This was a first result we obtained. Then, and this is the main topic of the talk of today, then we moved to defining a more sophisticated way to change the difficulty of the exercises. Many state-of-the-art systems for cognitive training have automatic mechanisms to to fit the difficulty of the exercises to how the subject perform in their execution. But the problem is that the way the exercise parameters are changed is defined by predefined rules. So the way the difficulty is modified is the same for all the patients. So, and this is also the way that our system as MSRAB does the modification of the difficulty. This is the rule. The difficulty of the exercise is increased when the patient performance overcomes the 80% of the maximums for 2 consecutive times. This is the rule that has been defined by expert rehabilitation, by clinicians, but this rule is the same for all the patients. So we decided to try to find out a more adaptive way to change difficulty, the difficulty of the exercises, and we decided to adopt a machine learning approach that is called reinforcement learning. It's an unsupervised approach, and basically the way it works is that the system is able to learn how to modify the difficulty of the exercises based on how the patients or the subjects that use the system interact with the system itself. So according to the performance, the system is able to give a higher or lower probability to an action that changes the value of a parameter that defines the difficulty of an exercise. So just to make an example, if for a patient A, for subject A, there is a parameter that makes the exercise more difficult than another, then the system can learn to not to increase the value of the parameters in order to improve the performance, but to increase another parameters. For another patient, could be another, there could be a different situation. So, for example, instead of parameter A, the system can learn to change parameter B in the same given situation. Okay, so we have defined a method to learn these adaptive policies, and this method has 2 phases. The first phase is to build a policies that is specific for a category of trainees. There can be patients or also healthy people, and then refine these policies dedicated to a category in order that it is further personalized for a specific individual of the category. Okay, we have the efficacy of our method is based on 4 hypotheses. I don't go into the details because I will talk about them later. And we have so far done experimentation in order to verify the first 2 hypotheses. Okay, so our first hypothesis was, okay, we first tried to demonstrate that a category policies learned for a category drive the cognitive training of a subject of that category better than the baseline mechanism that we had already in our system as MSRAB. So we recruited some university students, so the category we are focusing on is that of university student, and we trained 2 policies for 2 different exercises of our system. We did evaluation of two groups of patients that different from those who had trained the system. We did a training session with these two groups of systems. They were evaluated using the neuropsychological test before and after the treatment, and then we measured if there was a difference, even between the group who used the baseline system and the group who used the system using the policy learned with reinforcement learning. These are the two exercises we used. One was for attention and the other was for memory. And okay, these are the characteristics of the three groups that were involved in the experiment. And we evaluated the performance in this neuropsychological test before the treatment, and the performance was equivalent for the two groups. Then, after the treatment, one group used the system with the baseline policy, the other group used the system with the machine learning policy. We evaluated again the two groups, and both had an improvement in their performance, but the group that was trained using the machine learning approach improved more in their cognitive performance than the group that used the baseline policy. This means that for this category, our machine learning approach works better than the baseline. Then we try to refine the policy in order to have a fully personalized policy. And in this case, a third group obtained a performance that was not better than the group who used the category policy, but what is important, the training time was much less. So this means that even if with a fully personalized policy we were not able to further improve the cognitive performance, we achieved a significant result because the training could be much shorter in order to get equivalent result. So in the end, we have found first that our system with a baseline policy defined by a clinician was obtained a good performance. We obtained also that if we use our machine learning approach, we can obtain even better results in the cognitive performance. And for the future work, we want to strengthen the results we have obtained. We want to replicate the experiments with other categories of people. For example, for patients suffering of some cognitive disease, we have already some contacts in order to set up an experiment like this. And also investigate the influence of the degree of specificity of a category policy. So a category policy can be used for patient subjects that are similar to those for which it works well. This is another question. These are some publications. The most important ones are the last two. And these are the people that have helped in the realization of the system and also in the experimentation. Thank you for your attention. If you need some more information, additional information, these are my contacts. Thank you very much.
Thank you, Floriano. really interesting presentation. Is there someone who wants to post a quick question? We have a few seconds left. Just shortly, which was the exercise, the most important exercise where you reached the most gains with your system?
Okay, no, I cannot. Basically, we had two exercises, one for attention and the other for memory. For the exercise with attention, we had an improvement using the machine learning approach, but not so evident as the one that we got with the memory. This is because of the baseline policy that was used to change the difficulty of the exercise. It's a bit technical, but in the first case, the policies defined by the experts was much closer to the one that the system could learn, so the performance was not so different. In the second case, the system was able to learn a policy that was completely different, or, well, there were a lot of differences, and this is the reason why this means that the baseline policies was not as good as the experts thought it was.
Okay. Thank you for being here, and I hope to see you next year for some updates about this interesting project. I think it's important to invest in health. So thank you again for being a speaker of this FESCON. So, we see us in 20 minutes for the next track, which will be IoT and cybersecurity. And the moderator won't be me, will be Johannes Brunner. So, you will see here in 20 minutes. Bye-bye.